All right, let's go ahead and get started here. Hey folks, thanks for joining. We have yet another session hosted by the Med ISAL talking about incident response. In particular, we're going to talk about kind of three flavors of it. Just logistically, we will share the recording after the session finishes, as well as a link to the slides. And if you have any questions, don't hesitate to reach out. You can either put it in the chat or in the Q&A function, or drop Axel or I a note. Our emails are at the bottom of this first slide. So let's go ahead and get started. Axel, you want to talk about what we're going to focus on today?
Yes, sure. And thanks for everybody. Oops, sorry. Let me start again. Thank you, everybody, for joining. Yeah, as video was indicating in the introduction here, obviously, incident response is a very broad topic, right? It may be an incident at a fielded device at a customer site, and we're not discussing that today. That's a different flavor and separate topic. But it may also be an incident in your operational environment, right? That may affect your supply chain. That's one scenario we're going to discuss. It may impact your production or manufacturing environment. That's another scenario we're going to discuss. And then lastly, it may impact also hosted customer data that you may be hosting under contract with your customers. And we'll discuss that as a third scenario.
All right, so let's talk about customer data that potentially gets breached. So I think there's kind of multiple phases to incident response, but all of them have this kind of preparation phase, right? We don't just go into this without having any security controls in place or any processes. It's both a requirement of the regulatory expectation as well as just a better practice for security to really have some of this set up before you get started. So when we think about data in particular, one of the hardest things to do, but probably the most important, is having this idea of a data asset map. And that really means knowing what data you have and the criticality of its nature. So oftentimes we'll think, hey, if it's PHI related to our customers' customers, right, like a patient in a hospital setting, and we know that their security number is stored on here for whatever reason, right? That is something that quite obviously is sensitive data. What might not be as sensitive is, hey, is the design history file for our device something that should be considered sensitive? Probably, in all likelihood, right? So you want to think about what your classifications are and where your data ends up being hosted. For lots of folks, it ends up being a harder exercise than expected. And this is just talking about kind of the more obvious clinical patient data, not talking about like intellectual property or like legal things that you should have in your organization from the business side. But at its most simple, making sure at the very least you know where your PHI is probably one of the most important first steps to getting started here. And in that vein, why is PHI the most important? It's because you have a lot of legal expectations, right? For both HIPAA, GDPR, CCPA, all these kind of big regulatory entities that sit out there looking for looking out for patients. They really want to make sure that you understand what PHI or PII you have in place. And when it comes to that, once you've actually identified the pockets of sensitive data that is retained, you think about what security posture do we have on those. So a lot of times you start with having kind of access and encryption controls in place. That means knowing that it's encrypted both at rest and transit. When we have devices fielded at a hospital, if it's coming back to some cloud service that is being offered as a medical device manufacturer, you have to make sure that the pipe is secure as well, right? How the data comes back into your cloud. And then once it's hosted on the cloud security is its whole thing, right? It's its own challenge. And so making sure that you have the security controls that you need is the first step there. And then the other half of that is making sure you have access control in place. So there's this idea of least privilege that means only those who actually need the access are granted it. And if you don't need it, then you don't get it granted. And most often, a device manufacturer will try to make it easier or faster to support a customer, which can sometimes mean some of these access controls get a little dicey or harder to enforce. The last one talks about probably one of the, I think, unique things in healthcare, right? There's this concept of the BAA, the Business Associate Agreement. A lot of times when a medical device manufacturer is supporting a health system, they will have a BAA in place that has a lot of expectations built in around security controls. And that is not just it's not just for the continued operation of devices, but it's kind of the totality of data that HDO has provided to the device manufacturer. So really understanding what clauses are in there when you sell the device is really important for it to trickle back. And that, as someone who worked at a device manufacturer, that's often a big point of negotiation when working with health systems. So making sure that your sales team or whoever it is that's supporting that really trickles that back into your engineering practices, and you understand what security updates need to happen is quite critical. Axel, anything you'd want to highlight as a preparation point for a data breach?
Well, to clarify also, obviously, any regulation, and you give a couple of good examples here, has its technical aspects, how to comply with them on a technical level. It has legal obligations, like, for example, a breach notification, but it also has organizational implications, right? So, for example, under HIPAA, you need to demonstrate that you have regular HIPAA training for your staff. Even if you're a manufacturer of medical devices that hosts customer data, that is HIPAA type data, PHI, you need to demonstrate that your staff is trained on how to handle that data. Under GDPR in Europe, for example, you need to have a data protection officer, DPO, on board that oversees your privacy practices. So again, they are technical requirements that come straight out of the regs. There are legal obligations in case of a breach, for example, but there are also organizational requirements that you need to be aware of and need to address.
Cool. So if we continue on this path of, okay, we've done our preparation, something has potentially happened now, and we're dealing with a potential incident. What do we do to start detecting, or how to make sure once we detect something that we analyze it correctly? So most importantly, right, is in the sea of data, there's a lot of noise. So you really want to make sure you have some sort of monitoring mechanism in place, and you're able to identify when an alert occurs that it does actually mean something has potentially happened, right? One of the hardest things that we see a lot of times is that folks, it's almost like alert fatigue in a hospital, right? You just have alarm fatigue because you're constantly being told that something is wrong. You really have to dial in what you're getting alerted on so that you actually do something about it, and it's not just another sea of noise that you do nothing about, right? And then once you've identified if there's potentially a compromise, making sure there's visibility into who has access, understanding who could have potentially been accessing to it, and then determine if data was in fact exfiltrated or somehow manipulated or moved inside the organization. Once the actual incident has been identified as being a real incident, you're going to want to get other teams involved. It can no longer be something that your SOC is potentially dealing with in isolation. There should be access and a clear navigation to the legal team, to the privacy teams, understanding what the breach response plan is and being able to start executing on it. As part of that plan, there is likely a first step that says, let's determine the scope, right? Figure out how far and how wide there has been compromise, where it's been impacted, what data it is, whom is potentially impacted from a physical domain perspective, and then determining what happens for any legal requirements. Here we've outlined in particular HIPAA because PHI is one of the biggest concerns here, but making sure that you really understand what your legal obligations are and where you potentially need to work with legal entities and ensure that you're disclosing in the right process. And then from an operational side, what do you do, right? So something has occurred. We need to first and foremost stop the data exfiltration. So that means cutting off either access or blocking or somehow inhibiting their ability to do it. Now, this is somewhat, sometimes it can be more complicated than that, right? Imagine there is a nation state attack that's occurred for data and you want to get federal authority involved. At that point, it might not be the right answer to stop it. There might be a more complicated response to try to go after the nation state and demonstrate it for legal purposes. And working with kind of that extended team will let you know kind of what that next step is or what the strategy should be there. But oftentimes it will be making sure that the data is stopped from being exfiltrated. You isolate wherever that breach was, and you start looking at forensics around it, determine how did they get in, what was the path, what was the vulnerability. They think of it as almost a reverse threat model, right? You figure out what went wrong, and then you figure out how they got there through kind of exploring potential weaknesses. And then once you do that, you really want to start capturing all the evidence you can. Evidence is maybe too harsh of a word, but you really want to have some sort of documentation to show what happened and what data got moved and who accessed it and how. And once you know that, you can then determine, okay, what's our remediation plan? And the remediation plan can wildly differ, right? It can sometimes be limited to just changing the way access is structured. It could be completely changing what data is being captured and how you approach it. But really, at its most simple, making sure whatever the root cause was of the initial incident is actually resolved as part of your remediation plan is absolutely required. And sometimes if the data is stored in a backup that is trusted and secured and it was not compromised, then you can restore from that backup and you're able to continue operations.
If I'm allowed to
go for it.
add one point here, and another thing that is important and should be well planned out before the panic sets in is the preservation of forensic data. So video on this slide here talks about isolating affected systems. I've seen organizations that, again, in that initial wave of activity, started wiping systems, wiping hard disks, because that is a very effective way of removing viruses. However, that also destroys any forensic evidence that you may need later in a postmortem analysis, or also may remove any data that may indicate whether data was exfiltrated or not. The same is true for restoring from backup, right? Before you restore from backup, make sure you have captured everything that you need to capture with regards to the event from the target system. That's the only way you can make the right decisions, inform authorities with valid information, and also improve your processes going forward.
And that can be one of the challenges for security against kind of business need, right? Security needs want to preserve and make the time and effort to really ensure things are going to be resolved. Sometimes the business can prioritize, we got to get back up and running. We got to support this customer. We got to do something operationally. So that can be sometimes where there's a conflict of interests and sometimes be hard to actually do from a business priority perspective. And the kind of the last major phase, right? Okay, we've determined what happened. We've limited its exposure. We have a plan for how we're going to remediate. Who do we tell and how do we tell them? So there's a lot of mandatory breach notification expectations, especially for ePHI, right? Covered entities have expectations. Your BAAs awfully have some constraint. HIPAA obviously has expectations. Making sure that whatever you're obligated to do is understood well before this even happens is really an important first step, right? So when we talked about preparation, we talked about having that legal kind of laundry list of where am I obligated. From that, you should be able to derive, okay, should something happen, I know I have to speak to these 5 entities within 10 days. I know I have to speak to these 20 entities within 30 days, whatever it is, right? Making sure that is identified is really important. Which feeds right into this individual notifications. A lot of times when you have EAAs, there will be separate expectations with customers, and understanding what needs to be told to those folks will be part of it, as well as their customers, right? And then who communicates that, and how do you work with the entity that you're potentially related to, whether it's an HCO or otherwise. And then the last one is having some sort of after action review, right? We're all familiar with the CAPA process. This would be very much something that would feed right into that, right? Hopefully there's a tight coupling between your product development lifecycle and the security team. And that way, whatever learnings come from that after action review can feed right into your product development lifecycle and be able to take that lesson learned and kind of change, if necessary, how a device has been architected in a particular way. Before we go into software supply chain, anything, Axel, you want to highlight?
No, I made my points. Feel free to move ahead.
Cool. So the next major area we want to talk about is software supply chain. So what happens if something in the software on a device somehow compromised? So part of the preparation for this kind of incident, at the very minimum, software bill of materials. And I know this has been like a buzzword for the last, I don't know, 8 to 12 months, it feels like, and everyone's talking about an SBOM and you need an SBOM. But a lot of folks really struggle with that first step of, I don't know how to write an SBOM. Do I just write down what I know to be on my device? Is there a tool I can use? There's a variety of ways to skin this cat, right? But whatever path you choose, you have to make sure you don't just do it at a single point in time, but you maintain it over the lifetime of that device. If you're been around the medical space for a minute, you remember where there used to be an expectation for a hardware bill of materials, and that got scrapped from the post-market guidance from the FDA. That doesn't mean you shouldn't have it, right? It just means it's not part of what the regulator's asking for. You still need to have some knowledge of what hardware is on your device so that should an incident happen with a certain chipset, which is bound to happen, right? We have visibility into when you're potentially impacted, especially now as a lot of folks are picking chips for some sort of cryptographic accelerant. It's something that could potentially become more important as this kind of post-quantum world becomes real. So once you have, similar to kind of that asset mapping, you now have an inventory of all the software that's related to your product. You think about, okay, what's critical? What do I need to understand? What's not critical? What's more on the UI side, or something that is less important to operation, right? And then now that you have your inventory, in all likelihood, you aren't just using self-written software. There's likely some commercial software. There's likely some open source software. Making sure you understand what those suppliers are offering or not offering can then be part of how you build this, right? So if you have an open source library that is being maintained by one random person in the middle of nowhere, that has a very different security support expectation than perhaps some of the more well-maintained libraries that are out there. As part of using those, and this leads to the contractual notification clauses, right, is where you have the ability to enforce breach notifications from a commercial solution. That's something you should be aware of and be able to track and understand. Windows is kind of a great one here, right? You're getting notifications regularly, frequently. You're getting patches regularly, frequently. Again, that kind of leans on the side of too much noise and not necessarily knowing what's relevant, but at least you know that you're going to have some sort of support at a point in time, especially now with Windows 10 being done. It could be something you're facing imminently. And then the last bit, knowing what forensics and remediation capabilities you have legally as part of your agreements is something that could really change how you interact with your vulnerability exposure. Axel, anything you want to add?
And Matt, all of the things we went through to the complexity of your supply chain, right? Supply chain can mean very different things. It can be a supplied service, for example, a cloud hosting provider. Supply chain can be software that comes in through your engineering processes, right? Software that is vetted and built into your product as part of your development efforts and is approved to go into production. But it can also be, for example, firmware coming in on hardware that is built externally. How do you monitor that firmware that is not under your direct control? So again, it's a broad range on what falls under the umbrella of supply chain, and therefore it's also a broad range of compromises that need to be considered.
You want to take the next one?
Sorry. Yeah, and then with everything, of course, make sure you have the right ways to detect an incident, right? Make sure you monitor your supply chain, automated SBOM scanning, vulnerability scanning, monitor external sources for information, whether that is NVD, whether that is ICS CERT, whether that is organizations like Health ISAC, and others, FBI, FDA, you name it. So there's a long list of things you can certainly watch and should pay attention to. Make sure you analyze any incident and newly discovered vulnerabilities from a exploitability perspective, right? Is your device actually impacted by this? It could be that your supply chain notifies you about a particular new vulnerability that could be exploited, could become an incident in the fielded device, but the way you've implemented your software, you're not using that particular feature, therefore it is not exploitable in your implementation. So make sure you understand, again, the differentiation and avoid unnecessary fire drills. Make sure you scope the risk correctly, right? Make sure you understand the worst case scenario, whether that could lead to data modification, denial of service attack, could have impact on patient, on care delivery, and so forth. But also don't overreact, right? Make sure that again, the risk is scoped correctly in the context of your particular design, your implementation, and your device's use case, and then make sure that you as the manufacturer of the final product have good connections to your vendors, to your supply chain, but make sure that they have a way to alert you, make sure that you have a contact where you can go back and ask questions and understand if clarification is needed.
The only thing I would add, this isn't like a nice to have best practice. This is the expectation of the FDA, right? So the regulator expects that you are managing your software bill of material against some sort of vulnerability, and you have a process in place to assess those and demonstrate why you do or do not need to take action. Cool. So when we talk about what happens next, right? So you've identified there's something to manage. You know that the vulnerability is real. It's not just a false positive. What do you do now, right? So we think about how can we approach the software? Similar to kind of what we talked about in the prior one, right? You determine that you want to isolate that infrastructure if possible and figure out what that compromise is scoped to be. Where could it possibly lead? Does it impact the HDO? Is there a patch coming? Is there something we can develop from a mitigation perspective? There have been instances where we have heard of device makers telling a hospital to simply turn off the Bluetooth or isolate it on a network or stop using some component or facet of the clinical operation. There's a variety of ways that remediation can occur. Some can severely impact clinical care delivery, and some the patient or the provider won't even notice, right? So really ensuring that you have a strategy in place for the vulnerability is important. And again, this is one of those moments where security could butt heads with the business priority, and you want to work through that in a way that everybody comes out happy. Next bit can often be, hey, what do we do about this component? Is this vulnerability something that is not going to be remediated? Therefore, we need to move off it. Windows 10, another great example, right? For those folks that have in recent days tried to submit something on a legacy operating system to the FDA, they're asking a lot more questions about why are you doing that? And why are you not using some sooner version that has support by the vendor still? And so getting off of some of these old legacy operating systems becomes more obvious of a path forward. When we think about re-verification, right? So we think a lot about whatever the change is and how that changes our V&V process. This can be a time-consuming effort because sometimes it can be a 3 to 6 month window before V&V really catches up with whatever the software update is. And the FDA has repeatedly, and you can check their frequently asked questions, talked about how that cycle should not necessarily inhibit when an update or a solution gets pushed, but you need to somehow demonstrate it from a documentation perspective that it is safe and you are able to make a software update. And then obviously coordinating that with clinical operation, the user of the device, whatever your ongoing support cadence is really important. Similar with the other one, right? The next step of this is what did we learn? What do we change with how we operate? And so understanding if you have something that has to be submitted to the FDA or some some sort of regulatory authority is important, and you're going to want to be able to communicate that. A great example, I think QNX was, I don't know, 2-3 years ago at this point, but the FDA called up the ISAO and said, hey, we need to understand if MDMs are impacted. How can we work with the ISAO to do that, right? And then a lot of ISAOs had to then talk to the FDA. Sorry, not ISAOs, a lot of MDMs then had to talk through the ISAO to the FDA and make sure they were communicating where they were, what they had done, and how they understood to be impacted or not. Vendor accountability, so similar to kind of the other idea, right? Understand what your vendor is able to offer you, and if it's insufficient, or if they said they would have brief notification timings that didn't work out for you, you can work through that together and kind of figure out next step from there. And then the last one, I think, is really that process improvement, right? No process is perfect. There's always going to be opportunities to get better, but the SBOM management and monitoring is really one of those complicated ones that appears like a simple problem to solve, but is actually significantly more complicated to solve. And so it can be that there are constantly lessons learned in how it's being approached that could leave everybody a little bit happier. All right, last one. Axel, you want to kick this one off?
Sure. So obviously, a lot of incident response lies in the preparation, right? Having the right plans in place, having the right architecture in place, having your teams trained in incident response and learn from things that get found in the training. But best practices, you need to have an inventory, and you need to have visibility of potential redundancies that you may need, right? If you have mission critical systems, yes, there may be a requirement to have redundant fallback systems in place. So have an understanding, a real-time map of all deployed devices, identify which of your customers, which HDO relies on your devices, which version, which model, because not all incidents affect all versions. So you can, filter your communication down to what is really relevant. You may want to have, depending on the type of device, but emergency stock available so that you can potentially provide replacements for devices that are affected, or if there's a production shortage that you have stock you can fall back on, so you don't create unnecessary shortages. And of course, your device architecture, the device itself needs to be resilient. It should be still operating, maybe not with its full functionality, but at least with a basic care delivering functionality, even in a degraded state. And even if the device needs to be taken off the network, it needs to be air gapped to, for example, deal with a denial of service attack. It needs to be still functional and provide at least, again, basic functionality. Also, for your overall infrastructure, your environment, production, the climate control in your warehouse, your shipping and logistics, there are weak spots everywhere, and each of them can be impacted by a cyber incident. So look at established best practices on how to secure your operational technology. I always point to the Purdue model, which is a classic way that breaks down how to best, again, organize and architect a secure environment of operational technology. It doesn't matter whether that is your HVAC in your warehouse that controls the temperature, or whether that is the SCADA devices in your production environment. And then make sure that you also work with your customers in the partnership format. Make sure that you provide guidance on workarounds, provide guidance on when and if a hospital should fall back onto paper, and if a device needs to be taken out of operation.
So if you have an incident that leads to a shortage, I think there's kind of three major first steps, right? Clinical prioritization, really understanding the clinical setting and what you need to support first and foremost to make sure patient care can still be safely delivered, is the first step. The next one is whatever quarantine protocol you have in place, where Axel alluded to this, right? Understanding how you could safely take devices offline or potentially segment them without losing core functionality. That's the next major area. And then the last one is, imagine you do have an emergency supply in place that can be deployed rapidly to relevant locations. Get working on that and get some on-site support where you can help HCOs continue servicing their patients. Similarly, you have to have some communication expectation in place. I think everyone has the aspiration of letting folks know as soon as possible, right? But I think being realistic in how you can communicate to healthcare providers is really important, and what their expectations are should be managed appropriately. And not having over ambitious replacement or restoration timelines communicated or obligated, what will serve all parties, right? That way everyone can work under a realistic timeline. The regulator, there's immediate expectations for global healthcare regulators, right? The FDA, the EU, there's all expectations for what needs to be told to folks, and that can't really be moved around. And then the last one, if there is something that you can do on your manufacturing line and work with your manufacturing facility to kind of get yourself to a better spot relatively quickly, that's also possible. A great example, there have been instances where certain physical manufacturing facilities were co-located with other manufacturers, and they were able to work together to say, hey, let me take some percentage more of manufacturing capabilities in this short-term period, so that we can build back up, and that helps kind of get back on their posture so that they can have secure operation in the field. I don't know that I think this is a lot of repeating kind of what was historically said, right? But in summary, really having a plan for production challenges is important. And you might not obviously think, hey, security should be involved in this, but at every step of the way, the device then deployed also needs to be secure, right? So making sure that security has an engagement in here. We've seen recent recalls from the regulator that are security focused, that really require having a strategy in place for how to manage that. And increasingly, as we see GPOs kind of becoming bigger buyers in the market, we really want to ensure that there's a relationship there with how some of these devices get back out into the field, so that our ultimate consumer of the device is safe in care delivery. I know, whoops, I think that is the last slide that we had. If you have questions or want to talk more about incident response in this scope, please don't hesitate to reach out to Axel or I. And other than that, Axel, is there anything you want to add at the end?
No, there were two questions in the Q&A, which I just answered. So, so whoever posed the questions, again, if my answer was not clear, I typed some of it real quick, and I apologize. But again, here's our email, so feel free to reach out to us, and I'm more than happy to discuss further.
Thank you for staying on top of that. Appreciate it. All right, folks, keep well, and we look forward to seeing you on the next one. All right, take care. Bye.